Hello everyone, welcome back to another video. In today's video is going to be part 1 of factoring quadratics. So we're going to be covering quadratics that have the leading coefficient of 1 and follow the general pattern of ax squared plus bx plus c, where a, b, and c are numbers. In part 2, we're going to be looking at quadratics that have different leading coefficients. Alright, here is our first quadratic expression. We have x squared plus 6x plus 5. And you can see that in our first term there is no coefficient, or rather the coefficient is an invisible 1. Alright, so the first step to factoring a quadratic is to find a special set of numbers. And these two numbers have to multiply to give you the third term and add up to the coefficient of the second term. For our question, we're going to find two numbers that multiply to 5 and add up to 6. Okay, so because 5 is a prime number, the only factors are 1 and itself. And if you look at those two numbers, 1 and 5, they indeed do add up to 6. So those are our special numbers. We have 1 times 5, it's equal to 5, and 1 plus 5 equals to 6. Now the reason we're finding these two numbers is because we want to split up the middle term in our quadratic. That way we have an even number of terms and we can factor them into two groups. So let's rewrite our expression. We're going to bring down the first term directly, and we're going to split up the second term into plus 5x, which is one of our numbers, and plus 1x, which is the other number. And lastly, we're also going to bring down our third term directly. Now, as you can see, our rearranged expression doesn't look like our original quadratic expression. However, the value doesn't change because if you combine the middle terms, it will still be 6x. Now we're going to split our expression into two parts. And for each part, we're going to factor out a GCF, which we did in the last video. So the greatest common factor of x squared and 5x is simply just x. And we will divide each term by the GCF. So x squared divided by x is just x, and 5x divided by x is just 5. Close up those brackets and let's move on to the next part, 1x plus 5. So the GCF of 1x plus 5 is just 1 because it is the only number divisible by both terms. So let's make another set of brackets with plus 1 on the outside and x plus 5 on the inside. Now right away you can see that the contents inside the brackets are the same. So our final answer will consist of two sets of brackets. So in our first bracket, we're going to put whatever is inside one of those two brackets above, which is just x plus 5. And in our second bracket, we're going to put the GCF that we pulled out of the expression, which is x plus 1. And that is our final answer. X plus 5 times x plus 1 is equal to x squared plus 6x plus 5. Here is another quadratic expression that we're going to do. However, this one has a few negatives, so m squared minus 3m minus 4. Our first step is to find our special set of number that multiplies to negative 4 and adds up to negative 3. So some factors of negative 4 are negative 4 and positive 1, positive 4 and negative 1, and negative 2 times positive 2. So our special numbers are negative 4 and positive 1 because those two numbers add up to negative 3. So positive 1 times negative 4 is equal to negative 4, and 1 minus 4, or 1 plus negative 4, is equal to negative 3. Let's rewrite our expression. So m squared minus 4m plus 1m minus 4. Now split the expression into two parts again and find the GCF of each part. So factor out an m in the first part and we have m minus 4 inside our first bracket. Then we're going to factor out a plus 1 for our second part and we have m minus 4 in our second bracket. Now our final answer will be m minus 4, which is what's inside those brackets, and m plus 1, which is the GCFs pulled out of the expression. And there we go. The factors of m squared minus 3m minus 4 is m minus 4 times m plus 1. But because there is a negative in our question, let me show you what happens if you put -1 instead of +1 for your GCF instead. If you put -1, inside your bracket you would have -m plus 4. And if this happens while you're solving a question, you can see that what's inside of those brackets remain the same. However, their signs are just switched. So to fix this issue, we're just going to switch the signs of the GCF, which switches the signs of everything that's in the bracket as well. And that is how you factor out quadratics with the leading coefficient of 1. Thank you so much for watching, and I'll see you in the next part.